Can you guess what's the mechanism that governs the shower suction cup handle? Disengaged, no suction. Engage the lever, no way you're moving that. Disengage the lever, comes right off.
This video belongs to a playlist called the Mental Mechanism Library, in which we're going to study products all around us, figure out how they work internally, and save their mechanisms in our Mental Mechanism Library. This is going to make you a better mechanical design engineer.
Very simple cam mechanism. When you pull the lever, you can see the inside here. You have more room. When you pull it down, it moves the suction cup vertically in the Y direction. And let me show you what's going on inside. When you move it up vertically, it sucks the suction cup up, and that's what creates the vacuum here. And also, one thing to consider is this face of the suction cup will come in contact with this face up here in the handle. And that's what creates the seal on the outside that won't let the air escape. Now, it can be a little confusing to understand what's happening on the inside, but thankfully we have SOLIDWORKS CAD, and I can show you the interior so you can understand really what's happening.
So here we have the beautiful handle that I designed on SOLIDWORKS, and I'm going to show you what's going on in the inside. This is the beauty of CAD, that if we're going to explain mechanisms, we can see them three-dimensionally. When the handle is engaged right now, the distance from the center of the circle to this bottom face is larger than the distance when it is disengaged, right over here. So you basically want to move the rod up by actuating the handle, because when you move the rod up, we want to move the suction cup up because it's going to create a vacuum here. The air particles will escape. There's going to be less air particles, and we want this edge face right over here to come in contact with this face so we can seal the edges so no air can escape the vacuum or go in, vice versa. Very simple mechanism. One more time. Up and down. Now I'm going to show you who I learned how to model handles from. I have a legitimate resource, which is my mentor, Joko Engineer. He's a YouTube channel right here. Joseph Larsen, who you may see right here, and he's a handle design engineer at WL Gore and Associates. This is a very big medical device company, and he really knows what he's doing when it comes to handles and design. I actually met him on YouTube, and this is a podcast episode that me, myself, the co-host of the Being an Engineer podcast, I interviewed him, and we talked SOLIDWORKS, FreeCAD, calculus engineering, designing handles. So I encourage everyone to go check out that episode, and we specifically talk about handle design, something that we are doing today. Now I'm going to briefly walk you through some of the steps that I did to design this. As always, we start by importing an orthogonal picture of the item that we're interested in. I outlined it using, this is a little tip that I could show you actually. I wasn't planning on showing you this, but it's the style spline. So let's say, I like it a lot better than the regular spline. So let's say you want to do a spline, but they're hard to maneuver because they have those handles. Style spline is so much easier to edit and move around. So that's one tip that I learned from another senior engineer that has been teaching me SOLIDWORKS, and I want to pass on to you, my audience. Moving on, I created a bunch of planes. I learned from watching different YouTube tutorials, and then I did a loft feature. I'm going to remove the background, the picture in the background, so it's a little clearer. This is the loft feature that I did. You may have noticed I'm doing half of the handle, and at the end I'm going to mirror it. I created some surfaces. You'll see why later on. Some cuts. I'm working on the process of creating the handle, the actuating handle, which I will borrow the surfaces from the original handle part later on to create it. A lot of surfaces and thickening. Let's remove, there we go. I did a revolve feature on the inside to create some space. And then I want to show you my favorite SOLIDWORKS feature, which I have mentioned this in the past. It's the intersect feature. When two bodies intersect, you can do an intersect feature and delete the bodies you don't want or the ones you want to keep. So I deleted something that was up here. The key thing for that is you want to make sure your bodies are unmerged, so you have actual individual bodies that are intersecting each other. And the rest is pretty straightforward, just mirror to the other side. If you stuck around to the very end of the video, I want to reward you with an industry tip that's going to add to the value that you have as a designer. So you may have noticed a little strip in here, this yellow strip, which we suspect is something called UHMW. And I want to introduce you to this material. We're here in McMaster, something that most mechanical designers are very familiar with. This is where you borrow different hardware, you can download it and upload it to your model. And this is UHMW. So it's a sheet or a bar, something that has a low coefficient of friction, is usually used when you want to slide something and you don't want the surface, you do not want the surface to wear out. So you may add it, maybe this is a perfect scenario. So when I said we suspect, it's because we don't know for sure. I didn't really test the material properties, but it makes a lot of sense to put UHMW where the yellow part is. As you may notice, this, if I can click on it, this part right here, this curvature of the pink handle is gonna come in constant contact repeatedly on this surface. And that's why it's a perfect place for UHMW. If you appreciate this tip, if you like the video, like, comment, subscribe, and shoot me a message on LinkedIn. Until next time, Rafael Testai.